Now again, third degree means it has at most 2 turning points. If it's a negative and odd, that means it's going to start pointing up and end pointing down, because they have to be opposite directions. And then one real root means it has one x-intercept. So does anyone have an idea how we can draw this thing? Yeah, kind of like a snake. Something like this. Where it kind of starts up, it curves, goes through the x-axis, curves again, something like this. Does anyone have another idea? Where it has 2 curves and touches one time? Okay, another one?
No, I was thinking.
Alan?
Would it be starting above it, going below, going?
So it can only touch one time. You're on the right track. Anyone else have an idea? You're on the right track, Alan. You might make it?
Start up and down past the x.
Okay.
And go back up, but don't hit the past and go back down.
Perfect. Something like that. I'll draw a little bit better. So something along those lines where it starts pointing up, goes through, curves, something along those lines. But that little curve could have been above too. So there might be more than 2 ways. Something along those lines. Okay. The next one, 4th degree, positive coefficient, 2 real roots. So if it's a 4th degree, what's the maximum number of turning points? 3. Always one less than the degree. Positive, if it's an even degree, you know the arrows are going to point in the same direction, and if it's positive leading coefficient, we're structured, they're both going to point up. So they're both pointing up. And then 2 real roots. So how many x-intercepts are we going to have? 2. Okay. Any idea how we can draw this one? How about this? Can I make a W? 3 turning points, 1, 2, 3. Touches twice. If it's a 4th degree, is it allowed to have less than 3 turning points? Yeah, it can't go over 3. So you might also see something like this is a 4th degree. Touches twice. It doesn't go over 3 turning points. You can also see a graph something like that. It's also an example. Sometimes it has less turning points. Questions over that one? Number 3, 5th degree, negative leading coefficient in 2 real roots. So, 5th degree, how many maximum turning points can it have? 4. Maximum of 4 turning points. Negative leading coefficient, so really similar to the first one. Which direction is it going to point? Up, and it's going to end pointing down because it is odd, so they have to point in opposite directions. And 2 real roots, so how many x-intercepts? Well, long like this, it has to start pointing up. So they only touch 2 times. So what you might have to do on this, when it comes down, it touches, comes back up. Oh boy, I'm not a very good artist. Sometimes it can take a couple tries. This is what we're gonna do. Go through. Snake, come back up, touch, and then go back down. Something along those lines. So it has 1, 2, 3, 4 turning points. always go from left to right. That way you don't accidentally point in the wrong direction. Goodness gracious, please. Not the greatest artist snake. And then put it back down. Something, I know it just looks like a bunch of scribbles. I'm not the greatest drawers, but something along those lines where it curves, and like snake, it curves again, and then it goes. Questions over that one. Fourth degree, negative leading coefficient, 3 real roots. So how many turning points maximum can it have? 3, or it doesn't say one less than the degree, so 3 turning points, negative, and when it's an even degree, we know it's pointing in the same direction, so which direction are they both going to point? Good. Both ends are going to point down. And then 3 real roots, so how many times is it touch? 3 times, so it's going to 3x intercept. Any idea on how to write this one? Idea? How similar when we already drew that was fourth degree? Any idea? Megan?
Start down and then past the X intercept. Turn around,
Good. Touch, and then what are you going to do? Go back down. Perfect. Something along those lines. That's about the only one I can think. Someone, I'm trying to think of someone first period.
How do you know if it's just down or up?
If it's even, they have to point in the same direction. So if it's positive, both ends are going to point up. If it's negative, both ends are going to point down. If it's odd, they have to point in opposite directions, and it's flip-flops of what evens are. So if it's negative, it's actually going to start up. And if it is positive, it's actually going to start down. And the other end is going to be, there we go. The other end will be opposite whatever the first end is. Good. They have one where it's going to look something like this. Go up, curve, wait, hold on. Up, down, okay. Go back through. Curve, come back up and touch. Has 3 turning points, and both ends are pointing. So yeah, there's more than one way to draw these curves. Multiple ways. Questions over that? Sixth degree, positive leading coefficient, 0 real roots. So if it's a 6th degree, how many total max turning points can it have? 5. So there's 5 turning points it can have. Positive, so it's even is positive, so which direction are they both going to point? Up. Both ends are going to point up. And then 0 real roots. How many x-intercepts is it going to have? None. It's not going to touch the x-axis at all. Okay? Well, what's this graph going to look like? Kind of. It's got a bunch of squiggles. All right. But where do we specifically have to draw it? It has to be above because we're pointing up. If it was below, it ended up having to cross because it has to point up. So really, all you're going to do is just make something with like a bunch of 5 turning points, and it's just above the x-axis. So look, 1, 2, 3, 1, 2, 3, 4, something like that. You can maybe, I don't know if I can make it. 1, 2, 3, 4, 5, something like that. It has 5 turning points. It's above the x-axis, and both ends are pointing. Bunch of switches. Yeah, these are just switches. Okay. Number 6. This is 3rd degree, positive leading coefficient, real roots. Well, third degree, how many turning points does it have? 2, at most 2. Positive leading coefficient and it's odd. So where does it start? Full flop it. Down and up. So when it's odd, think opposite. So positive is actually going to start pointing down. And 0 real roots. So how many x-intercepts is it going to have? None. Well, how can we draw this? What's this graph going to look like? Why? Yeah, good. The ends are going in the opposite direction, so no matter what you do, you have to cross the axis at some point, because one is pointing down, the other is pointing up. You have to cross it eventually. So this is a situation where it's not possible. Anything that has an odd degree, unless it's linear, there's a special case, it has to cross the x-axis at least one time. So an odd function is always going to have at least one real root. Not possible. Has to have at least one real root. Odd. Has to have at least one when it's odd. Evens, like number 5, yeah, you're allowed to not have any x-intercepts because the arrows are pointing in the same direction. So that's a situation where it doesn't have to necessarily cross the x-axis because the arrows are going to point up or both are going to point down. When it's odd, they're pointing in opposite direction, so it's inevitable. It has to cross at least one time. Right. Questions over that? Second degree. Positive coefficient 1 real root. So how many turning points does the second degree polynomial going to have? 1. Good. 1 turning point. Positive. It is even. So which direction are both ends going to point? Up. And 1 real root. So how many x-intercepts is it going to have? 1. Oh, what is this guy going to look like? Look at you. And what part of that U is going to touch? Vertex. So it might look something like this. Oh boy. Your actual kind of touches. Or it might look something like this. Something along those lines. Questions? Okay, we're reading a couple on the back just to refresh your memory. And then you'll have those to do on your own. And then you'll get more practice over the creating graphs. Don't misplace it. Keep it because we're going to go over some of those on Thursday before you take your quiz just to refresh your memory. So don't misplace it. I'm going to give you a data class. It's important. So here's just what we did before break. Just refreshing your memories. We'll do one of these guys together and you'll be able to do the rest of them. So end behavior. Remember when it has x pointing towards negative infinity, that just means the left side of your graph. So you go to the left side of your graph, and which direction is it pointing? Up. And so if it's pointing up, that means it's pointing towards infinity. Okay. When x is going towards positive infinity, that's just the right side of your graph. If it's to go to the right, look at what direction is it pointing. Pointing down towards negative infinity. So that's all what that means by end behavior. Number of turning points. How many turning points does this graph have? 2. 1, 2. 2 turns. So if it has 2 turning points, what's its least degree? 3. Because it can have 2 turning points and be bigger than 3. So it's at least 3. So the degree is odd And the ends are pointing up and then down. So is the leading coefficient positive or negative? Negative. Okay? Think kind of like opposite of what you think for odd functions. Negative is pointing up. Positive starts down. Okay? So that's essentially what you're doing for the rest of them. Questions over that? Okay. Finish up those 5 on your own. The questions happy to help, or if you need your answer checked.